Rational functions. So a rational function is a function where our numerator and denominator are polynomials. It is represented here on this diagram here, which is fx equals px and qx, where both of them are obviously polynomials, but qx cannot equal 0 because that's going to be undefined. So to find vertical asymptote, all you do is you set the denominator equals 0. To find horizontal asymptote, you gotta look at the degrees of the functions. That's gonna be on top and the bottom. So it's gonna be on the numerator and the denominator. If we're gonna represent our n as our numerator as n and our d as denominator. So if my n is less than my d, my y is gonna equal 0. If my n is equal to 0, my y will be the ratio of the leading coefficients. If my n is greater than d, there's no horizontal asymptote. To find symmetry, all you do is you set your rational function to be f of negative x rather than f of x. If those equal to each other after being set to f of negative x, then you have an even y-axis symmetry. But if you set it and you don't get the same values, then you have odd or origin symmetry. So let's move on to an example with all of this. So that's going to be here. Sorry. So how you do this is you have 3x. Oh, that's glitching, but that's all right. This is the question here. I've solved the most steps to save a bit of time, but I'll explain everything. So what you do is you have 3x squared plus 9x minus 12x squared x minus 2 minus 4. So what you do is you just simplify this down. Oh, sorry. Oh, there we go. That's what I want to see. So wrong color. Yep, there we go. So what you do here is you have 3x squared, and all you have to do is you just factor this down to the most simplified it could be. So in this case, it's going to be 3 x plus 4 x minus 1 divided by x plus 2 x minus 1. So, knowing this, we have both x minus 1 here and x minus 1 up here. Well, this is what you call a hole in the graph. So, where a hole is, the graph is going to be undefined. But for now, we're going to keep it here because we are going to plot this on the graph. So, because we're going to plot it on the graph, let's move on to horizontal asymptote. So, in our case, horizontal asymptote, our y is equal to -1. Well, you might ask why. Well, look at the degrees up top. So, 3x squared, that has a degree of 2, and on the denominator, we have a degree of x squared. Both of these values are leading coefficients. Well, because what on that rule, it says if both of our leading coefficients have the same degree, then we divide each other. So in this case, we divided by 3 and 1 because there's a hidden 1 here. 3 divided by 1 will be 3. But since we have a -4 here, that's going to come down here. So that's going to be 3 minus 4, which is going to be -1. And you always write horizontal asymptote y equals -1. So to find vertical asymptote, our vertical asymptote is x equals -2. And that's because we set the denominator to equal 0. So x plus 2 is equal to 0, and then we take the 2 here. That's going to be x equals -2. But remember, we don't use x minus 1 since it's both in the numerator and denominator. It will be undefined since we're pretty much just dividing itself, which is going to be 0. So looking at y-intercept, all you do is y-intercept equals x equals 0. Uh, Putting x equals 0 here. So that's going to be 3. 0 plus 4. 0 plus 2 minus 4. That 3 times 4, that's going to be 12 divided by a 2. 12 divided by 2, that's going to be a 6. 6 minus 4 will give you a 2. So since our x is 0, we write it like here. The other thing so the other thing we're going to do quickly is we're going to look for the hole. So looking at the hole, so I'm going to just write hole here. So looking for the hole, we know our x value of our hole by doing this. X equals +1. how I got that is I just did x equal, sorry, not x equals, x minus 1 equals 0, and I solved for minus 1. So I just moved that here. That gave me the value up top. So that's going to be x equals 1. Well, what's our y value? Because that's how we plot it. To find y value, all you have to do is you put it in our polynomial here. So that's going to be 3. 1 plus 4, that's going to be a 5. Divided by 1 plus 2, that's going to be a 3. Well, and minus 4, obviously. 3 and 3 cancels out. That's going to be 5 minus 4. 5 minus 4 will give you a um, equals to a positive 1. So our whole is going to be at 1 and 1. So graphing this will be really simple since we figured out everything. So that's going to be one line down here, down here. Let's go for some points. So that's going to be 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. Negative 2, negative 3, negative 4, negative 5. Okay, so this is our points, and so let's graph everything. So let's start off with graphing the horizontal asymptote. Well, graphing the horizontal asymptote is really simple because it's at y equals negative 1. Y equals negative 1 is on the y-axis, negative value here. So this y equals negative 1 is going to be around here. We look at vertical asymptote now. Vertical asymptote is going to be negative 2 since it's here, so it's going to be down here. Now let's start by plotting the smaller points that we got. So let's start by graphing our y-intercept. So it's going to be at 0 and 2. So x at 0 and positive 2. So that's going to be positive 2. And our whole will be at 1 and 1, which will be around here. Yeah. So graphing that is gonna look something like this. Let me change the colors so you can see the graph clearer. So it's going to be something like this. And then from here, it's going to go down. So if you want to figure out how exactly the graph looks, all you have to do is get values from here and plug it into our expression here. Obviously, without the x minus 1, since it's not part of the graph anymore, because that will be a whole. So this is what this will look like. So let's quickly look at the domain and range of a graph like this. So our domain, obviously here is negative infinity, and here is positive infinity, negative infinity, and positive infinity. So looking at that, so our domain, so from negative infinity to here, which is going to be a negative 2 union. And then from here, since there's a hole here, we go from our negative 2 to 1. We look at the x value of that. And then from that 1, we go again to positive infinity. So that's what's here. So for the range, it's going to be the same thing. So from negative infinity, we go to negative 1. And then from 1, we go to, from negative 1, we go to positive 1. And then from 1, we go to positive infinity. It's not here for some reason, so I'll just write that. So it's gonna go from that's not supposed to be negative 2. That's gonna be so from negative 1 to, that's gonna go from negative 1 to positive 1, and then from positive 1 again union. So from positive 1, it's gonna go to positive infinity. That's gonna be our final answer. All right, here's another question. I'm just going to quickly explain it. So we have fx equals x minus 1 as numerator divided by x squared minus x minus 6. Well, first thing we're going to do is we're going to factor our denominator. That's going to be x minus 1 divided by brackets x minus 3 brackets x plus 2. So in order for us to find vertical asymptote, all we do is we set the denominator to equal 0. So that's what we did here. So that's going to be right here is what we did. So that's going to be x minus 3 equals 0. Negative 3 to the other side, x equals 3. And then we did that again to here for the positive x plus 2. That's going to be x equals negative 2. So we have two vertical asymptotes, which is a lot different from the other question. Now, let's look at horizontal asymptote, which is around here. So horizontal asymptote, again, what we do is we look at the degree. Well, over degree here, that's a degree of 1 here we have a degree of 2. Well, since these are both the leading terms, when our denominator has a greater degree than 1, so 1 is less than 2, or our numerator is less than my denominator, our horizontal asymptote will always be 0. So looking at x-intercept, our x-intercept is y equals 0. To find it, you set y equals 0, and then so that's going to be 0, x minus 1. You bring this entire thing here, so that's going to be multiplied by 0, so that's again going to be 0, so that's going to be 0 equals x minus 1. We're going to bring the 1 to this side, so that's going to be 1 equals x. So, and then to find the y-intercept, you set x equals 0, so that's going to be 0 minus 1, 0 squared, negative 0. So all of the zeros are going to value nothing. That's going to be left with negative 1 and negative 6. Negative and negative will cancel out. That'll give you a 1 over 6. Next, find symmetry. There's no symmetry in this graph. Why? Because f of minus x is equal to negative x minus 1, negative x squared, minus x minus 6. Well, in this case, there's nothing here that represents our values up here. So over here is not similar to anything down here. Therefore, there will be no symmetry. So let's quickly graph this. So our vertical asymptote will be at x equals 3 and x equals negative 2. So let's graph the negative 2 value here, and then positive 3. So that's going to be around here. And then now we're going to graph our x-intercept. X-intercept will be at 1. So it's going to be at 1 and 0. So where will our 1 be? So our 1 is here and our 0 is here. So that's going to be our x-intercept. And then y-intercept will be at 0 and 1 over 6. So that's going to be around here, I'd say. So if you want to plot these points again, all you have to do is plug in numbers from our x values here. So it's if you want to figure out what's for negative 1, you just plug in negative 1 up here, negative 1, that's going to be a negative 2, so on and so forth. But since time crunch, I'm just going to draw you a simplified version of the graph. So that's going to look something like this, and then this. All right, thank you.